In 2009, China produced fewer than 500 electric cars in an industry dominated by gasoline engines and foreign brands. 15 years later, it became the world's largest electric vehicle market, accounting for more than 60% of global EV sales. In 2023 alone, over 9 million electric cars were sold in China, more than the rest of the world combined. What happened in between was not an accident of technology. It was a deliberate industrial strategy that is now reshaping global manufacturing, energy markets, and the future of transportation. To understand the scale of this shift, we need to begin with a structural weakness. In the early 2000s, China was already the world's largest car market by volume. But it did not control the core technologies of the automobile. Internal combustion engines, transmissions, and key intellectual property were dominated by foreign automakers such as Volkswagen and General Motors. Chinese firms assembled vehicles through joint ventures, but the most profitable and technologically advanced components remained imported. This dependence created a strategic dilemma. Competing directly in gasoline engine technology meant challenging a century of accumulated expertise in Germany, Japan, and the United States. Electric vehicles offered a reset. The technology was still immature and battery costs were high. Charging infrastructure was limited to run electric vehicles. No country had established clear leadership for EVs. But for policymakers in Beijing, this was not a risk, it was a big opportunity. Rather than trying to surpass foreign firms in gasoline engines, China decided to leapfrog them by investing in electrification. The first wave of serious policy began around 2009, when the government launched pilot EV programs across selected cities. Consumers received purchase subsidies that sometimes exceeded $10,000 per vehicle. Municipal governments were instructed to electric bus and taxi. In cities with severe air pollution, license plate restrictions for gasoline cars were tightened, while EVs received preferential treatment. For example, in Shanghai, gasoline vehicle license plates could cost tens of thousands of dollars through auction systems. The policy logic was clear: reduce oil dependence, clean urban air, and build a domestic high-tech industry simultaneously. At the same time, China faced a domestic problem that made electrification urgent. Rapid industrialization had caused severe air pollution in major urban centers. Oil imports were rising quickly, increasing energy insecurity. By 2013, China had become the world's largest oil importer. Electric vehicles were seen not only as an economic opportunity, but as a strategic solution to pollution and dependence on foreign energy. But this transformation did not occur smoothly. In the early years, many EV startups failed. Battery performance was inconsistent. Range anxiety discouraged consumers and subsidy fraud cases increased. By 2016, the government began shifting from direct subsidies toward a dual credit system that required automakers to meet new energy vehicle quotas. Companies such as CATL expanded rapidly, investing billions into research, supply chains, and production capacity. What made China's EV expansion different was its integration of the entire supply chain. Companies such as CATL and BYD invested heavily in battery production. By 2023, CATL had become the world's largest EV battery maker, controlling more than one-third of global market share. China also secured dominant positions in battery minerals processing, refining more than 60% of global lithium and over 70% of cobalt. This vertical integration lowered costs dramatically. In 2010, lithium-ion battery packs cost over $1,000 per kilowatt-hour. By 2023, average prices had fallen below $140 per kilowatt-hour. As battery costs dropped, EV prices became competitive with gasoline vehicles, especially in urban markets. Lower battery costs translated directly into more affordable vehicles. Infrastructure expanded alongside production. By 2023, China had installed more than 1.8 million public charging points, accounting for roughly 65% of global public chargers, according to the International Energy Agency. This big charging network created tension. The European Union launched investigations into Chinese EV subsidies. The United States imposed tariffs on Chinese electric vehicles. The debate is no longer about whether electric vehicles are viable. It is about who will control the global supply chain of the future. This shift is reshaping energy markets. China became the world's largest oil importer in 2013. Analysts estimate that gasoline demand in China has plateaued due to EV adoption. As renewable electricity capacity expands, particularly solar and wind, electric vehicles further integrate into a broader decarbonization strategy. In effect, China is electrifying transport while simultaneously scaling renewable power generation, reinforcing both industries. There is also a deeper technological transformation underway. Modern Chinese EVs function as digital platforms on wheels. The vehicle is evolving from a mechanical product into a digital platform. This convergence between automotive engineering and consumer electronics positions China at the forefront of smart mobility systems. However, the story is not without risks. Rapid expansion has created intense price competition. Profit margins are thin, and weaker firms are exiting the market, raising questions about sustainability. At the same time, global supply chains remain vulnerable to political friction and resource constraints. China's EV revolution demonstrates how coordinated industrial policy, infrastructure investment, and scale manufacturing can reshape an entire sector within a generation. The cause was strategic necessity, pollution, energy security, and technological dependence. The event was sustained state-backed investment combined with fierce market competition. The impact is a structural shift in global transportation, energy demand, and industrial power for other countries. The lesson is not simply to replicate subsidies. It is to understand the importance of ecosystem building, supply chains, infrastructure, research capacity, and market incentives aligned toward a clear objective. Technological revolutions do not occur in isolation. They require policy consistency, capital commitment, and domestic competition capable of driving down costs. For consumers, the shift means vehicles that are quieter, increasingly affordable, and digitally integrated into daily life. In China, it has become the default choice for millions of families. That transformation is not just about cars. It marks the beginning of a new technology era. If you're getting something from this video and want to stay ahead of the economic curve, take a second to hit the like button and subscribe. Thank you for watching. See you in the next video.